Alright, so this video is going to be a review of vectors. So you might remember this stuff from pre-calculus, you might also remember it from physics, maybe from some other classes. So first, what is a vector? If you think about forces, velocity, acceleration, anything that involves movement of an object in a specific direction, but it also has speed to it or something like that, we represent those with vectors because they have two components to them. So we're thinking about things that cannot be characterized completely by a single number. They have to have two things to describe them. They have a magnitude or a length, and they also have a direction. So a vector is called a directed line segment, and its magnitude or its length is denoted this way. So we're going to say the magnitude of PQ. So sometimes they write it like this, sometimes they do 2 bars. It depends on the textbook that you're working from. And in this class, I'm pretty sure that we're just going to go ahead and write it like this. I didn't double check your textbook, but my notes write it like that. All right, so in textbooks, vectors are often denoted by lowercase bold letters such as U, V, or W. In this class, we're always going to write them with this little arrow thing at the top. So vector U, vector V, and vector W. So you have 2 points in a vector because vectors are line segments, so they stop, they don't go on forever. The arrow tells you the direction that the vector is going. It doesn't tell you that it continues. So the initial point is P, the terminal point is Q, and this vector goes from P to Q. All right, vectors are composed of an x direction and a y direction. We call that the horizontal component and the vertical component. So we could say this is like your horizontal component, this is your vertical component. So whatever number you had for how far apart these points are, whatever number you had for how far apart those y values are. So we have 2 different forms that we can write vectors in. One is the component form. So if you write the component form, then you'd say vector v is whatever that horizontal component is, whatever that vertical component is. And then the other form we have is the linear combination form. And that's ai plus bj. And that's whatever this number was. So if it was a horizontal component of to the right 3 and up 4, then you would say 4i, or to the right 3, I said 3i plus 4j is what it would have been. So these forms are very closely related. You just need to know the difference in what they're called so that when a problem asks you to put the form in a certain answer, you know what that answer should be. So the standard form of vectors is to take the vector and start it at the origin and then have it move from there. We can write any vector in standard form by subtracting the points. We always do end minus beginning. And I would say circle that, highlight that, whatever you need to do. So here we could say that the component form of vector v is 3, 2. And if you wanted to find the component form using vectors, vector u right here, then we would say r is the point 1, 2, s is the point 4, 4. And so to find vector u, we would do 4 minus 1. So I'm subtracting the x coordinates, and I'm doing the end minus the beginning, and then the end minus the beginning for the other one. And I would see that these 2 vectors are actually equivalent. And that's because a vector is actually the direction that it's going, so kind of like the angle that it is and the length that it is. A vector is not defined by where it is located on a graph. So these 2 vectors, even though they're in different spots, they are actually equivalent vectors. All right, on the next page of the notes, we're going to make sure we remember what the parts of a vector are. So I already mentioned the 2 parts. They are the magnitude and the direction. The magnitude is the length of the vector. It comes from the distance formula or the Pythagorean theorem. So here they've described this side length right here as the x coordinate v1 or the horizontal component, and then this part right here is v2 or the vertical component. And so the distance or the length of that segment right there would be that the magnitude of the vector is the square root of the horizontal component squared and the vertical component squared added together. And that's just the distance formula between 2 points, or Pythagorean theorem. To find the direction, or to find the angle that a vector is heading, the angle the vector forms with a positive x-axis. So this right here is always how we're going to label the angle. And you have 3 different ways you can find it. You can say that the angle, you can use cos theta, sine theta, or tan theta. So if you use cos theta, then you're going to use the opposite side over the hypotenuse, or sorry, the adjacent side over the hypotenuse. So that is V1 over the magnitude of V. The sine would be opposite over hypotenuse, so that's V2 over the magnitude of V. And then tan would be opposite over adjacent, so V2 over V1. And I would say that we're actually most often probably going to use tan theta, because that's just the y divided by x, the vertical component divided by horizontal. All right, so next we want to look at some vector operations. So here we have 2 different vectors we're looking at. One is vector u, and the horizontal component is u1, the vertical component is u2. Then we have vector v with a horizontal component of v1, a vertical component of v2. And then we're going to have a scalar c. And a scalar is just kind of like if you make something 3 times as long, or you make it half as long, or you make it negative, or something like that. That's what a scalar is. So when you're doing vector addition, if we did vector u plus vector v, we would add the horizontal components together, and we would add the vertical components together. If we're doing subtraction, we're going to do the same thing, but with subtraction. So I would do subtracting the horizontal components and then subtracting the vertical components. And of course, as always with subtraction, the order matters. So if you're doing u minus v, then these should also show up as u minus v. And then for scalar multiplication, if we said something like c times vector u, then that would be c times u1 and c times u2. So the operations work probably the way that you think they would. All right, for a unit vector, in many applications of vectors, it's useful to find a unit vector that has the same direction as a given vector. So it means it makes the same angle with the positive x-axis. Because it's a unit vector, it has a length of 1 unit, which is why it's given the name unit vector. So the formula to find a unit vector is you're going to say u is the original vector divided by its magnitude. So, and the original vector, remember, is written as the horizontal component and the vertical component. So you're going to have 2 different numbers here that you're dividing by the magnitude. All right, sometimes we are given information, like instead of them giving us points to write the vectors from, they actually say what the magnitude is in the direction. So they might give us an angle. It's a 35-degree angle, and it has a length of 5 units. Or it's a 15-degree angle, and the magnitude is 5 miles per hour, or something like that. Then we can write the vector in the component form, saying the magnitude multiplied by cos of the angle for the horizontal component, and the magnitude times sine of the angle for the vertical component. So that makes sense because this is like x and y. And you can also do, instead of component form, you could do the other form. So we would say, we would not have these little things out here. We would say, again, the magnitude times cos, but this time we would put an I on the end, plus the magnitude times sine, and this time put a j on the end. All right, so now we're going to go ahead and do a few examples of these. So here they give us 2 different vectors, and they're saying find half of vector v. So we're going to say this is half of vector v, which would be -1, 5/2. All right, for the next one, we're going to do vector w minus vector v. So first I'm going to go ahead and write them down, and then since I'm subtracting, I'm going to go ahead and distribute this negative. So 3, 4, now I'm going to add them, 2, -5. So that gives me the vector 5, -1. And then last, we're going to do vector v plus 2 times vector w. And I'm going to distribute that too. So that gives us 6, 8. All right, so when we add those together, we get 4, 13 for the resultant. And the resultant is whatever vector you get after as a result of doing the operation. All right, for this next one, it says we have point P and point Q, and they want us to find vector PQ. So we remember that we're going to do the end minus the beginning to do that. And then after that, they want us to find the magnitude of that vector. So vector PQ is going to be -2 minus 3, and then 5 minus -7. So that vector is -5, 12. And then they also wanted us to find the magnitude. So that is the square root of the horizontal component squared and the vertical component squared. So we have 25 plus 144, which is 169. And so the magnitude of that vector was 13. All right, for example 5, they want us to find the unit vector, and then they want us to show that it has a magnitude of 1. So the unit vector for PQ would be -5 over 13, 12 over 13. So that's using that formula that we talked about on the previous page. Looks like this, so the vector v divided by its magnitude. So we took the original vector, -5, 12, and we just divided it by the magnitude of 13. Now they want us to show that this unit vector does have a magnitude of 1. So I'm going to say the horizontal component squared plus the vertical component squared. So that gives me 25 over 169 plus 144 over 169. And when I add those two fractions together, I get the square root of 169 over 169, which is the square root of 1. And the square root of 1 just equals 1. So we proved that our unit vector has a magnitude of 1, which is the definition of a unit vector. All right. Next, they want us to take u and, oh, this is a typo, this should say v. So vector v. And I'm going to go ahead and write them in the same notation. So this is 2i minus j, that means it's 2, -1. And they want us to do 2u minus 3v. So 2u minus 3v. So that's -6, 16. And -6, +3. And they want us to write the answer as a linear combination. I'm going to go ahead and add these together first. So that's -12, 19. So for me to write that answer as a linear combination, I'm going to say -12i plus 19j. So there's the component form, there's the linear combination form. All right, last it says given that v has a magnitude of 6 and a direction of pi6, write v in the component form. So the component form was magnitude times cos of the angle or the direction, and then magnitude times sine of the direction. And since these are values, if you can simplify them, you should. Those are angles that are on the unit circle. So on the unit circle, pi 6 shows up right there. And that's a point of root 3 over 2, 1/2. So if I say that cos of pi 6 is root 3 over 2, then that's 6 times root 3 over 2. Sine was 1/2, so that's 6 times 1/2. And so the vector is 3 square root 3 and 3.